Hey Tech Math, here are the lesson notes for 13.2 about angles and angle measures. So I'm not going to read this whole thing, but the general idea that I want you to get out of this is that an angle in standard position has different parts. The first part is called the initial ray. That's what I've already done here. So the initial ray starts at the vertex and it extends along the positive x-axis. That is the initial side. We then have something called the terminal side, which has its vertex in the same place, but it is where our angle ends. So I have the initial side and I have the terminal side. I would label this on your paper. It's really hard to do in Smartboard, so I'm not going to. But I also then draw this little arrow to indicate the direction of my angle. So the other thing I want you to notice about this angle is that any angle that starts with the same initial side and ends with the same terminal side, regardless of angle measure, is going to be coterminal. So for example, if I started here and I went up and I went all the way around this circle and I ended up at this ray. So I started here and I ended here. Even though these two arrows have two different angle measures, they are considered coterminal angles because they share the same two sides and the same vertex. So that is what it means to be in standard position and to be coterminal. The next thing you need to understand with angles and angle measures is their direction. If we start at the positive x-axis and go up and go towards the positive quadrants, my angle is going to have positive direction. Notice this is a positive 225, so therefore my angle's positive. However, if I start at the positive x-axis and go down towards the negative quadrants, my angle is going to have negative direction. So let's draw these angles in standard form and see if any of them are coterminal. I'm going to keep doing these in different colors. So they're all going to start on the same positive x-axis. So I'm going to go through right now and just immediately know that my initial side is always going to be right here. I would suggest that you grab a protractor from the bookshelf so that you can make sure these are not only accurate, but they also have straight lines. I can do it with the Smartboard tool here, and it'll give me a straight line. And I also know pretty close to what each of these looks like, but if you don't, please grab a protractor and make it accurate. Alright, so if I start here, notice I have a positive angle, so I need to go in the positive direction. And if I want to reach 150 degrees, there's 90. I need another 60 degrees. Well, there's another 30, and I'm about 30 away from this final axis. So I'm going to, again, make sure that I am drawing this arrow of direction so that I know which direction I'm going at all times. You would not want me to think that this was a negative angle because you forgot this little arrow. With the second angle, it's just a little bit different because instead of being a positive angle, now we have a negative angle to work with. So instead of going up towards the positive quadrants, I'm going to go down towards the negative quadrants. And I'm not going to go to negative 210 where that would be. So like if I went up this way, 210 degrees would be right here. I'm not just going to say, oh, that's where 210 is and here's where it's negative. That's not how this works. I'm going to start my measurement at this side and go 90, 180, 210. And I did this and I measured in the negative direction. This is the most common mistake I see from people is they say, well, 210 would be right here, So I'm going to mark 210 and then I'm going to draw my arrow towards it. You have to measure all the way over. That was bad. I'm going to try that again. That's a little bit better. So there's 210 degrees. All right, let's keep going with the next two. This one, positive 120. We're going to start at that vertex and we're going to go up because it's positive. There's 90. There's 120. It's about 30 degrees past that angle. I'm going to do this one real quick and then I'll add that little line as well so that we remember. But I do want to do this one while I have this tool on. 480 degrees. This is positive, so I'm going to start here and I'm going to go up. I have to go a full 360 degrees around. And then in order to get to 480, I have to add another 90 and another 30 to get to about 120 degrees here. So now how do these two arrows look different? They look coterminal, but how do I know that these are two different angle measures? Well, that's why I waited to do this. 120 degrees in the positive direction is shown with this arrow. If you want to show that you went around more than one time, you actually have to make the loop with your arrow more than one time. This shows me that you went around 360 and then added an additional 120. So let's go back and address the question. Are any of these coterminal angles? Yes, they are. I have two angles here that are coterminal because they both end about 30 degrees away, exactly 30 degrees away from this negative x-axis. It might look a little rough just because my arrow wasn't quite where it should have been, but these two are coterminal. These two are also coterminal. They have the same initial side, they have the same terminal side. Again, notice, they do not have to have the same angle measure to be coterminal. They must only start and end in the same position. All right. Draw an angle 240 degrees in standard position. Got it. Quick, do that here. I'm going to start. I'm going to go in the positive direction. There's 90. There's 180. There's about 30 degrees away from my 270. And then, of course, I draw my arrow. Now, how do I find a positive and a negative coterminal to this? Well, positive is really nice because just like I showed you here, to find a positive, all I need to do is add a full rotation. So let's do that. 240 plus one full rotation gives me another positive coterminal because I'm still going in the positive direction. And I end up at 600 degrees. Now, could I use this same method and subtract that 360 to find my negative coterminal? Yeah, I absolutely could. I'd end up with negative 120 degrees. Now, I could have just seen that I could have measured this angle and said, well, this is negative 120. But this is also a really easy way to see how to find those two measures. All right, let's keep going. We are now introducing radians. And while degrees are what we are really comfortable with, radians are a lot simpler to work with once you get good at them. And I think that this drawing's a little challenging to understand. So I went to mathisfun.com. It's one of my favorite websites. Yes, I'm nerdy. And I love their description of radians. So I'm going to show you their little piece that they have here. So a radian is the length of your radius wrapped around your circle. And it's about 57.2958 degrees. That doesn't really matter to us. I want to show you this so you see where we're getting the radian from. They're going to take the radius, and they're going to put it on top of the circumference of the circle. That is what they are defining as 1 radian. Well, how many radians does it take to get all the way around the circle? This is where I think the cool part comes in. If we keep taking this radian measure and we keep going with it, notice it takes about pi radians to get 180 degrees. Well, if it takes pi radians to get 180 degrees, how many does it take to get 360? 2 pi. So I'm going to pull this away. I'll link that if you want to mess with that image a little bit more. But the big idea here is that the circumference of any circle is going to be 2 pi. There we go. 2 pi r, where r is the radius measure. So the circumference of a unit circle, the thing that I've shown you here, where the radius is always exactly 1 unit, it allows us to get rid of the r variable and just say that the circumference is 2 pi. Therefore, an angle representing 1 complete revolution of the circle measures 2 pi radians. So 100 degrees is exactly pi radians. Ooh. Let's see if I can put that pi somewhere more convenient. It's being challenging. Pi radians. And if we want to do half of 180, we want to know what 90 degrees is. Well, that's just 1/2 of pi. So pi over 2. Wow, struggling with typing, I guess. Let's put it right here and we'll say pi over 2. Alright, I'm going to pause the video right here because I'm running out of time on my screencast. But I'm going to jump back in right here in the second video, so please go check that out now.